हेलो। ओके, शुरुआत करते हैं पीरियोडिक टेबल से। चलो, पीरियोडिक टेबल, मॉडर्न पीरियोडिक टेबल लॉन्ग फॉर्म होता है। मॉडर्न पीरियोडिक टेबल मोजले का एक्सपेरिमेंट अंडर रूट म्यू जो है डायरेक्टली प्रोपोर्शनल टू जेड होता है एटॉमिक नंबर। अंडर रूट म्यू इज इक्वल टू ए जेड माइनस बी। जेड माइनस बी कांस्टेंट, ए और बी कांस्टेंट होता है, जेड एटॉमिक नंबर होता है, फ्रीक्वेंसी होता है म्यू। उसके बाद फिर मॉडर्न पीरियड मूसली का एक्सपेरिमेंट ये बताता है कि अंडर रूट म्यू जो है जेड के अकॉर्डिंग कांस्टेंट इंक्रीज करता है, बट ए मतलब एटॉमिक मास के अकॉर्डिंग मतलब नॉट कांस्टेंट ऑन समथिंग रहता है। मॉडर्न पीरियोडिक लॉ, प्रॉपर्टी ऑफ एलिमेंट फिजिकल एंड केमिकल बोथ आर पीरियोडिक फंक्शन। फिजिकल और प्रॉपर्टी ऑफ एलिमेंट फिजिकल एंड केमिकल बोथ आर पीरियोडिक फंक्शन। तो बोथ पीरियोडिक फंक्शन होता है of their atomic number. Some important points: trans uranium element after uranium atomic number greater than 92 और trans uranium element। जो एलिमेंट यूरेनियम के आगे है उसको ट्रांस यूरेनियम एलिमेंट बोलेंगे। मोस्ट ट्रांस यूरेनियम एलिमेंट आर आर्टिफिशियल और मैनमेड। जितने भी सारे ट्रांस यूरेनियम एलिमेंट है वो सारे आर्टिफिशियल या मैनमेड होते हैं। तो टोटल नेचुरल एलिमेंट 94, टोटल नेचुरल एलिमेंट 94 होता है। ट्रांस यूरेनियम एलिमेंट फाउंड इन पिच ब्लेंड। पिच ब्लेंड में हम लोग को पाया जाता है, पिच ब्लेंड में हम लोग को एनपी पाया जाता है, एसी पाया जाता है, पीयू पाया जाता है, पीए पाया जाता है। बट ट्रांस यूरेनियम जो है वो एनपी और पीयू है। तो इस पेज में क्या चीज़ था, इस पेज का समरी ये है कि v इज इक्वल टू ए ब्रैकेट में z माइनस बी। उसके बाद फिर मॉडर्न पीरियोडिक लॉ, periodic elements physical and chemical property both are the periodic function of their atomic number. This is the second point that we got from this page. Then after trans uranium element after uranium 92 से it's greater than 92 and most of the trans uranium element are artificial and man-made. Then that's the summary of this page. Let me write it somewhere. Do it with red pen. I don't have any other slides. That looks nice. Periodic table. The first point is under root mu. Under root mu means under root frequency is equal to A, which is a constant, Z, which is atomic number, minus B. This is moles experiment. The second point that we can write is transuranium equal to atomic number greater than 92 and total natural element is 94. The NP and PU is, then we can remember that NP and PU are those elements which are transuranic and also are present in uranium core, or which we call pitchblende. The other thing is and out of 94 elements is now. So why is there it's like transuranic elements are mostly human made, but there are 94 elements. So why it's there? Like why the controversy? So out of 94 natural elements, there are 6 to 8 elements which have very less natural abundance. Like they are found very little in nature, or if found, they are very unstable and very unstable to extract from it, and or very stable ore, so it can't be extracted. So they are prepared only by synthetic methods in lab using nuclear reaction. And the first man-made metal was Tc, technetium. The only lanthanide which are prepared artificially is PM. PM. I don't really know what PM is, but no, never mind. Typical element. Typical element is the element of third period, and sodium to chlorine are called typical elements as they exhibit typical property. Generally, all of their group. It's like they exhibit all of the group's property, so it's typical element. Bridge element. According to modern concept, Li, Be and B are called bridge elements as they exhibit diagonal relationship. They exhibit diagonal relationship with Mg, Be with Al, B with Si. Why they show this relationship? The reason is similar pi value. Pi value means charge on cation divided by size on cation. Rare earth metal. Rare earth metal are lanthanoids. Lanthanoids are rare earth metal because they are not really found in earth. That is a myth, or that is a false statement. They are called rare earth metal because they are very similar in nature and rarely separated from their ore. They are very hard to separate from the ore. So because they have very similar properties, so they like metalloid. The example of metalloid is Shiv Ji Sab Tere Puja at AS. Shiv Ji Sab Tere Puja at AS. This is something we got to write. SIVGSBEPOATAS. Okay, nice. Metalloid is Shivji Sab Tere Puja at AS, and the AT is metalloid, but even it's counted in metal also. The first priority is metalloid, of course. Which of the following terms are which of the following atomic number of the liquid metal and liquid non-metal? The following the metal which is present in liquid form at room temperature is Hg. Hg means mercury, and the non-metal which are present in liquid in room temperature is bromine 35. Liquid metal are HgCs, Fr and all. Liquid room temperature here. Gaseous element, there are 11 gaseous element. 11 gaseous element. Glenn Seaborg discovered most of the transuranic element from 94 to 104. Glenn Seaborg did discover most of the transuranic element from atomic number from 94 to 104. 94 to 102 is the like correct thing, and 94 to 104 was the question something. Element having atomic number 106 is called Seaborgium, and with respect no, to give respect with Glenn Seaborg and all. Okay. First metal is called alkali metal. First group is called alkali metal. Second group is called alkaline earth metal. 15th group is called the Nicogens. Nicogens is like it's amphoteric and bad smelling. 16th group is called chalcogens. It's O producer, like oxygen type group. O which tells you people something. O sulfur, oxygen sulfur style like this only. 17th group is halogen, seaweed. 11th group is coinage metal. 12th group is volatile metal. Okay. Magic number 2, 8, 8, 18, 18, 32, 8, 8, 18, 18, 32, 18, 18, 32. It's like a number in by this interval 1 and 2 we have 2, 8, 8, 18, 18, 32, 8, 8, 18, 18, 32. Third one goes same 18, 18, 32, but the fourth 12th was 232, 18, 32, 32. 13 is like 8, 18, 18, 30, 32. And 13 and 17 is 8, 18, 18, 30, 32. 18 is like 8, 8, 18, 18, 32. No 2. UPSC name the element having atomic number greater than 100. 0 is called nil, 1 is called un, 2 is called byte, 3 is called try, and 4 is called quad, 5 is called pred, 6 is called hex, 7 is called hep, 8 is called oct, and 9 is called not. Not 9, and 9 is no in German. Okay, I always want to put German. 104 O'Neill quadrium. So the American thought it would be named after Rutherford, so Rutherfordium, and Soviet thought it. Soviet just gave its name Kurchatorium, and what the fuck was that? I don't know. Okay. Classification of periodic table based on configuration S block. S block, last electron enter S block subshell or configuration noble gas, and S 1 to 2 outermost shell number and period number. Helium is considered in S block, but it is kept along noble gas in P due to its complete field valence shell. Hydrogen resembles both alkali metal and halogen. This is something I want to write. Hydrogen resemble both alkali metal and halogen. Hence, it is given a unique position in periodic table and kept separately at the top. P block, last element enters in P block, generally outer configuration, noble gas, NH2 or NH3 1 to 6. वैगन आलू गाजर थैला चाहे सीता गीता सुने प्रभु फिलहाल नाना पाटेकर ऐश्वर्या सब बीमार वो स्टाइल से ठीक हो फिर कल बाहर आना आंटी हीना नीना और कोरिना के एक्सपेरिमेंट there is no exception in N plus L rule or war rule in S and P block. The reason of it is large energy gap between S and P orbital. There is large number of exception of N plus L rules in D and F block. Reason to be precise is due to lower energy gap between N minus 1 F to N minus 1 D and NS orbital. Secondary reason is stability of half incomplete field orbital or structure is more stable than uh, non-half field or non-full field. It's like they prefer to be 5 out of 10 rather than 6 out of 10. Half field is better than more field. That's what to say. Okay, D orbital best configuration is n minus 1 d 1 to 10 and s 0 to 2. Okay, the fourth series of the element is 3d 4d 5d and 6d. After that 7d is not formed because lack of element. Then after PCCE their configuration are different in classes. Class 11, class 11 and okay, PC and CE have controversial configuration in the 11th and 12th textbook. We follow class 12 textbook. PC is equal to KR 46 5S 1. The 3D series goes like सुनो तुम विवाह कर लो मुझसे फिर कोई नहीं कहेगा. Okay, the 4D series goes like यारी जरा नवा मौत तक फॉरवर्ड पड़े तो आग में खोदो. The 5D series goes like ला हफ्ता वरना वो फायर रोड से पिटेगा और हंसेगा. So unethical, but okay, never mind. AC to LA is exception because of this, and actinium to lanthanum exception because of the Saville rule. Okay, series goes like actually the other four Dupa Saga. It's like we are telling that we are telling Saga that Rutherford has drowned. So Rutherford Dupa Saga was high Hasna and the other one took it as a joke and started laughing. So and then we say bhai Hasna to stop them from laughing. Dogs are wrong. Jen is coming and the doctor named Ron Jen is coming to save the life of Rutherford. I block the last electron enters the f orbital or subshell. General configuration is n minus 2 f 1 to 14 n minus 1 d 1 to 0 to 1 and ns. Lanthanide is on the upper side and actinide is on the lower side. They both are considered in third group, third B group. Largest group is the largest group. Lanthanide 4F series ferrous metal N is equal to 6. Actinide series 5F series. Okay, now if you go ahead, the configuration on the basis of groups and period we have discussed it all, and now we are going towards Bose classification. The Bose classification represent main group element, like it only represent S and P group because it's only main group. Transition metal, they act as bridge between highly reactive S block element and less reactive element of group 13 14, and they are called transition elements. Okay, transition metal is like uh, a bridge between highly reactive S block element versus less reactive element of group 13 and 14. So it helps to connect those two those two environments. According to IUPAC, they must process at least one unpaired electron either in atomic form or in ionic form. But the exception is Zindagi Kaddu ho gayi, and Zn, Cd and Hc are not considered in transition metal. Non-typical transition metal they are called so because they don't fulfill the criteria of being an transition metal. The criteria is uh, the criteria is I don't know why, but when I study, I get sleepy. Never mind. The criteria is at least one electron must be unpaired in all conditions and neutral or in ionic condition. In a transition metal, F block elements are in a transition metal. Region lanthanoid are considered to be members of 6th period and actinoid are members of 17th period respectively, and both belong to third group. Okay, it's inner transition. The chemistry of early actinoid is more complex than corresponding lanthanoid. Region lanthanoid was a fucking region. Oh, the reason is that actinoids who have more oxidation state, or they are very less they are very less stable and more reactive. So it evaporate or ice can disintegrate into air within nanoseconds. So it's not very easy to study. The the periodic table consists 78% in it is metal. The metallic character increase down the group while the non-metallic character increase across the period. Max total number of electron in pre-ultimate cell is pre-ultimate cell is the cell before the ultimate or donor cell. The donor cell is n n1 and the pre-ultimate cell is n minus 1, and n minus 1 we can have like in n minus 1 we can have like 2 2 okay. Or D block. For being in D block, the pre-limited cell. For being in D block, the D block goes in n minus 1. So the 1 comes from there, and n minus 1 you also have as and P. So the 2 electrons of S and 6 electrons of P. The total connection is 2, 6, 8, 8, 8 and 1, 9. 9 and the P can also fill up to be 10. So 9 to 18 is the best guess I'm going with. Max total number of electron of ultimate cell of S, P, D and F block represent 2822. Okay, got it. Nothing to write here, or all thing you already know. The above will be followed, then lanthanum. The above rule is followed, then lanthanum and actinium bridge would belong to F block. Okay, the above, if the above is not followed or is ignored, the lanthanum and third will belong to F block. PD is single. I'm sleeping. No man. I don't know. Just stuck up. Okay. The PD is the only element in the periodic table which constitutes 18 element in ultimate cell. The example of PG is a very exception. It is very dangerous exception because the ultimate cell, if we look at the expression of it, we know that it's 4, but it's not 4, it's 5, because the 5s does not have any electrons. It gives all the electrons to 4D for completing its orbital. So we do say that fulfill is far greater stable than half-wave. Lanthanum and actinium both contain 14 electrons each. For this structure होना चाहिए orbital can accommodate maximum 14 elements. Block period group determine if the atomic number is given. Check if given atomic number of the full range. If we have to say like the question is like check whether it lies in F or D block or any other question. We are given a set of numbers. So what we are gonna check is if this number doesn't follow the given following ranges 58 to 71, it follows F block 6 period, and 61 to 30 103 it is length night, and downtime period underground or one. The thing is that ahead of 104 the one, like ahead of 104 atomic number syncs itself to the period number, I guess, last digit. Like ignore the 1 in 104, the 4 will be 6. Give us the right block of this number. If below, if the range is not between 58 to 71 or 61 to 103, let's see if I get it right. 58 to 71 or 90 to 103. 58 to 71 or 90 to 103. 103. That's 103. 58 to 71. Okay, I got it. So if we don't have any of the numbers between the range, so it's not our desirable number. So what can we do? The period number is the period of next noble guess. Like if we got 30, if we got 34, the next noble guess is 36, and the noble guess which have 36 number is 2 2 8 2 10 15, like that. 2 10 18 16, like we have 4 8 8 and 12. The group number is founded by 18 minus atomic number of next noble gas minus given noble gas, like 18 minus atomic number of next noble gas minus given atomic number. If GP number comes negative, then subtract from 32 instead of 18. The GP is like this number. Okay. If outer configuration are given, if the outer configuration are given, we can easily find out the block, the period and the group number. The block is easy. The block is like the number. Block is the number last electron, the last orbital, the electron at first. block is that orbital. Like if the number goes to s orbital, last the block is s. If it goes to f orbital, the block is s. That's like that. Period. Period are decided by the ultimate or the outermost shell number with the period, and that's all. The clock determination I told Nitya which was it. Okay. Maximum number of elements in a period. Maximum number of elements in a period. You can calculate. Maximum number of elements in a period. The total number of elements in nth period is n plus 1 whole square divided by 2. If the n is odd or the odd, we have to make it even and we have to increase the number. So for increasing, we have to add first and then check if it's odd or even. If it's odd, we have to make it even. So if it's odd, like it's 3. So for making it even, we just have to add 1. It's 4 and it's 3. And if the number is 4, the given number is 4. For increasing the number, we have to first add something, and after that, to make it even, the number is already even, so we add it from 2. So n plus 1 or n plus 2 whole square divided by 2 gives us the total number of elements in a period. Total period subcell. Total period subcell is like total element in a period divided by 2. It's all under what the fuck is it is all under it is all under root. Periodicity, repetition of similar property after regular interval of atomic number. It's like the atomic number repeats itself like 1, 2, 3. No, the atomic number doesn't repeat itself. After certain atomic number, certain interval of atomic number, the property repeats itself, like the screening property, the atomic size property, the ionization property, the electron gain enthalpy, the En property. So the reason for this repetition is similar outer electronic configuration. Similar outer electronic configuration means the valence shell does have same type or same multiple of electron in outermost shell. So it's the reason. Shielding effect of Z effective. Screening or shielding effect is like when we shield something, we protect it from something, and when we protect something, we often repel something from. We often repel the thing that attacks what we are protecting. Okay, so screening effect is just like that. Screening effect is applied by the electron between the valence electron and the nucleus. So it acts like a barrier for the valence electron, and the valence electron or we call the reference electron get two type of force. Like the force which is attractive is attractive force, and the force which is not attractive and is repelling, it's called screening effect. And the screening effect is the net attraction. After that, we find out the net attractive force on the outermost electron by just subtracting the Z, or we say the nucleus charge minus basically repulsion. The calculation of shielding effect is done by Slater. Slater is hell of a case. I don't know how we calculated this. But for n cell it's 0.345, n minus 1 0.85, and for n it's 1. N minus 2 it's 1. For two species it's 0.30. For two species it's 0.30. For normal period, for a period it's horizontal. For a normal period, the shielding effect increases. Why the fuck my neighbors are? I'm very annoyed by that. Never mind. In a normal period, shielding effect increases by a factor of 0.35. Hence, Z effective increases by 0.65. Okay. In the transition series, as the new electron enters the n-1 cell, the shielding effect by the factor of 0. It's like the shielding effect. If the shielding effect increases, the Z effective decreases. If the electron enters in the nth orbital, then the attractive force increases more than the repulsive force, and when the electron enters in the pre-ultimate cell or pre-penultimate cell, then the repulsive force is more than attractive force, so the net attractive force is literally negative, or literally existential, non-existential. And group of Z effective increased by 0.9 while moving from second to third period. It's like we are moving in a period now. Okay, if we move downwards the group, after moving from second period to third period, after our Z effective increases by 0.9, but below third period, the effective remains constant according to Slater, but it doesn't apply as well. For the same cell, like the electron enters in the nth cell for 4 times as PDF, all 4 times in different orbital. According to Slater, or not according to Slater, I don't know who's according to is, but not according to Slater, I don't know. Order of shielding effect is S is greater than S is greater than B, P is greater than D, P is greater than F. F is like negligible shielding effect, so it doesn't matter. It does not apply very well, and the S and P does have very good shielding effect, so it matters. Shielding effect matters. Reason the D and F orbital have larger and diffuse size shape, like it's very diffuse, so it's like dividing the ball of air or ball of electron into 16 parts and taking one lobe of it. It's 1 by 16, and in S and P is like dividing the lobe into 2 parts and choosing the one, so it's 1 by 2, and 1 by 2 is obviously greater than 1 by 16 and all. In every group there is presence of D and F orbital in the inner shell which have 4 shielding. So the inner shell does have 4 shielding effect. So Z effective increases below 4th period. So the Z effective increases because the F orbital is introduced in 4th period. Okay. The next thing is contradiction to third results of splitter. So the third result of splitter is corrupt, and the third result of splitter is that if we move from second to third period, the shearing effect increases by 0.90, but if we move down to it more, the shearing effect is constant, but it's not, it's scientifically proven. Statement 1, chemical reactivity of the period decreases up to middle of the middle max at the group 17. The reactivity in the period decreases up to middle and become max at 17. Okay, got it. And the chemical reactivity increases on both groups. Okay, both statements are true by my side. Atomic size, we are studying atomic size, so it's like we don't measure atom literally. We don't measure like literally one atom can't be, it's not measurable. So what we do is we measure a molecule, or a molecule as measurable, so we measure a molecule of like diatomic molecule. So it's like we divide the intermolecular distance by 2, or interatomic distance by 2. It's not very accurate, sometimes it's more and sometimes it's less, so we'll talk about it. An atom does not have fixed shape and sharp boundaries, and the thing is atom does not also have sharp boundaries, so we have to uh, scrape what's left. So exact size of isolated atom can't be determined because it's very hard. Some indirect method are used to calculate the atomic size approx bonded state. So I said like bonded state, molecular state. Covalent radius. The first type of radius is covalent radius. Covalent radius is a covalent bond is mainly formed between non-metal, calculated in solid state using X-ray diffraction method. The unit of this radius is in angstrom and pm. Here what here covalent radius. Covalent radius of Cl is internuclear distance between Cl atoms, Cl nuclei we can say, by 2. Half of the internuclear distance between single covalent bond atom like Cr of n can be calculated from okay. Cr of so in this question we been asked like we need to find the covalent radius of an nitrogen. So what we can do is we find a molecule in which nitrogen is directly bonded to nitrogen and there's only a single bond present. So the terms and condition, if it's the right word, so metric radius, and we say the covalent radius is generally less than the atomic radius, and the metallic radius is generally more accurate side because metal are very closely bounded. So distance between adjacent kernels is nucleus. If we remove the nucleus electron, the remaining thing is known as kernel. The van der Waals radius is more maximum time more than the actual radius. Is used to for noble gas or non-metal which does not bound with anything or is hard for binding with anything. Calculated in solid state using X-ray diffraction, and the van der Waals radius is basically 2 times of covalent radius. And the example of it doesn't matter. Okay. Creation of periodic table. Creation of periodic table is if we move from left side of the periodic table to the right side of the periodic table, the Z effective increases drastically because the atomic number increases and the proton increases. So proton increases Z by 1 and Z effect shielding constant decreases it by only 0.35 or 0.85. So their effective increases and size decreases, because if the attraction increases, the size decreases. It's simple. Noble gases effectively exceptionally large atomic number as calculated only. The noble gases only can be calculated by van der Waals force, because van der Waals radius, because it's not suitable. Noble gas must be compared with van der Waals radii of other elements. Order of van der Waals, what's the order of van der Waals? It's same, like if we move from left to right, the effective increases and size decreases. In transition series, if we talk about transition series, the order of CR or MR is taken. The CR is scandium increases up to ferrous. Ferrous is then equal to copper, then equal to cobalt, and then equal to nickel, and it's smaller than copper and smaller. Then what we can see in this is the refractive dominates slightly, size decreases slightly, and the middle part shows us that both part dominates very well, but the end part says that the refractive does not able to dominate the size. So order of MR is MR does have something like CR and MN is the same. Notable non-metal atom S3 block, valence shell and outermost shell are same shell. For B block element N-1D plus NS valence shell, because both of them form bonding in valency, and NS outermost shell. Order of MR, strategy required to break extra stability of PB5 is PB third IP, which is very high. Only 2 electrons participate in MA molecular bond. Okay, why Mn is greater than Cr in molecular metallic radius? Because when we talk about Mn, the kernel is 7.2 and the bond which are we breaking is PB5, so it's very not dense. But if we talk about Cr plus is in the state of plus 6, then its kernel is very strong because of the plus sign, and we have seen that the effective increases with the positive sign. So that's that. The size is mostly proportional to the Z effective. Size increase, division number of cells, division number of cells increases. The extent of increase become less and less, Z effective increases. S block, what's S block? S block, the exception in S block is CS is equivalent to Fr and P is equivalent to radium due to lengthening contraction. P block is Alu and Gajar, and in Thela it's all equal set. SN and PB, so no problem, it's equal set. The reason is lengthened contraction. The upper reason Alu Gajar is transition contraction. D block, third group and third group and 12th group. Okay, third and 12th follow this shit. Third is 3D to 4D, size increases. 4D to 5D, size similar. Okay, 3D to 4D size increases. 4D to 5D, size similar. Third and 12th group does follow this. Third is the reason for third is natural contraction. The reason for fourth is value based. जिंदगी कबाड़ा हो गई एंड सुनो ये what the fuck is लाएंगे, लेकिन हियर लाएंगे ऐसी जीना जरा है एक फर्स्ट रदरफोर्ड, वो नवाब था दाबा करोड़ में विलियम साइन, मंतकरे फोले रूठा ओसामा हसीना, कौन रूठेगा इन नंबर मैथ से, रैशनलाइजेशन नंबर मैथ से नहीं पड़ेगा, पिटेगा नंबर मैथ, दिस इज order size unlimited access or something है. Okay, got it. Lengthenite contraction. The lengthenite contraction is the reason for regular decrease in atomic number and ionic sizes while moving from La to Lu. Called lengthenite to pure or negligible shielding effect. Due to poor or negligible shielding effect, 4 of orbital electrons that effective increases decrease in ionic size, and 3 is regular but increase of atomic size. There is one exception, U. U is the greater, has the largest atomic size among lengthenite. U is the largest atomic size of lengthenite. Not applicable. It's like thing. It's like lanthanide construction applicable for lanthanum to lanthanide. Lanthanum does not import to lanthanide because it's another thing. But thing is, the next thing is due to the larger size of 5f orbital, its SE is less than 4f orbital. Lanthanum contraction is more prominent and less dominant than ACC contraction. AC contraction, what the fuck is AC contraction?